Hi friends, in this video I'm going to discuss about Lambda expression feature in Java 8. It's a very important feature as it allows us to write functional style code in Java. Let us see the agenda now. We will start with why Lambda expression in Java and then what is Lambda expression, followed by Lambda expression syntax and then a short demo. And we will end the video by touching upon the concept called variable capture in Lambda expression. At a high level, let us understand lambda expression before seeing why lambda expression in Java. A lambda is a set of instructions that can be saved as a variable, passed around the program and executed a later time. This allows us to write functional style program, that is treating behavior or function as first class citizen. Even before Java 8, Java was capable of doing functional programming, but in a disguised way. For example, we were able to define a contract for behavior using interfaces, and we implement the contract in a class or in an anonymous class. By this way, we add a behavior to the class and we pass it around. In this screenshot, calculatable is an interface and the class multiply implements the interface calculatable. So we create the class multiply and assign it to variable C, which is of type calculatable. Now we can pass this object C to any method which accepts the interface as a parameter. We have been doing this way because objects are first class citizen in Java, but this adds lot of boilerplate codes, and we add a new class just to implement the behavior and use them as a carrier to pass around. Sometimes this makes code very cluttered and difficult to follow, but Lambda allows us to work with functions in a simpler way without any disguise. Now let us see what advantage Lambda brings in. Lambda's new syntax element increase expressive power of the language. That is, it reduces unnecessary boilerplate code and enables developer to write concise code. We will see this with an example during the demo shortly. Lambda allows us to take advantage of parallel processing by passing behavior to the method. For example, prior to Java 8, if the processing of elements in a collection had to be done in parallel, then the client code has to be written to perform all the steps to parallelly process the collection. But with Lambda expression and streams API, we can pass processing logic to the collection, and now collection is responsible for parallel processing and not the client. This simplifies the client code in large. And more importantly, it allows collection code to fully utilize the multi-core capability of modern processors. What is Lambda expression? To answer this question, we need to understand two constructs. The first is the Lambda expression itself. The second is the functional interface. Let's begin with the simple definition of each. A Lambda expression is essentially an anonymous method. However, this method is not executed on its own. Instead, it's used to implement a method defined by a functional interface. Thus, a Lambda expression results in a form of an anonymous class. Now let's see what is a functional interface. A functional interface is an interface that contains one and only one abstract method. It is also referred to as single abstract method SAM. For example, the standard interface runnable is a functional interface because it defines only one method, run. Java 8 supports Lambda expressions only with functional interface. A functional interface defines the target type of a Lambda expression. That is, Lambda expression should match method parameters, return type, and exceptions thrown by a method in functional interface. These conditions are not new. It is same as while implementing an interface in a class. Let's see the syntax of a Lambda expression. Hyphen followed by the greater than symbol is called Lambda operator. To the left side of the Lambda operator is Lambda parameters. So there can be 0 or more parameter. So it totally depends on what is the method signature present inside the functional interface. Okay, to the right side of the Lambda operator is Lambda body. It can contain a single line expression or it can be a multi-line block of code. The following table describes the different things we need to take care when you are using a single line expression or a multi-line block of code. In the first row, so it talks about when we need to enclose the lambda body within the flower brackets, that is a curly bracket, right? So if it is a single line expression, it is not really required to enclose within the flower brackets. But if it is a multi-line code, it's a block of code, then definitely it has to be within the flower brackets. Okay. So in the second row, we talk about the explicit return statement. Say consider in a functional interface, the method signature talks about a return type. So if it is a single line expression, so you're writing the lambda expression for that method. So when you're using a single line expression, you no need to specifically mention any explicit return statements, because whatever the expression returns, the compiler will consider that as the return type or the value to be returned. Okay, because the compiler does not have any confusion. Okay, so only one line is there, and whatever the expression returns, that would be returned. But when it comes to a multi-line code, definitely there should be an explicit return statement about what value has to be returned. So because compiler, there is no way for the compiler to know what value it has to return until unless there is a specific explicit return statement. Let's see a quick demo. We have seen this code snippet earlier. Here calculatable is an interface which contains single abstract method operate, which takes two integers as parameter. And then we have a multiply class which implements that interface. So inside the demo class main method, you see we create an object of class multiply and then assign it to variable C, which is of type interface calculatable. And then we call the operate method on that interface. So this is the typical implementation. We implement the interface and then use it here. Right. So you can see that for each class and interface, we have a class file created. Once we run this code, we get the result, right? So let us try to use anonymous method in this implementation. Right. Let me remove this creation of the class multiply and then create an anonymous class, right? And then let me also remove this multiply class, right? So you can see now here, still we have the class files for the interface and then a demo class, and then we have one class file for the anonymous class what we have implemented here. So now let's run this and still we will get the result. And now let's try to see how to use lambda expression here, what we have discussed. See, as you can see, this is a functional interface. It contains only one single abstract method, right? So just once again giving the name of the interface and the name of the method and its return types are redundant, right? So compiler can infer because there is only one single abstract method, right? So let us remove this and then we can try to keep the implementation similar to what we have seen in our syntax slide, right? When we discuss the syntax of a lambda expression, let us try to give the syntax as we seen there, right? So it's these are all the lambda parameters. Yeah, so within the brackets, so these are fine. And then let us write a lambda operator. Okay. So to the right side of the lambda operator, we have lambda body. In this case, we have the lambda body enclosed within the curly braces. So we need to have a explicit return statement. Okay. Now this is the lambda expression. Let us run this code. Now we will get the result. Fine, the same result, right? And one more important thing to see here, you can see that for this lambda expression, you don't need, there is no additional class file created. Okay. So now the compiler, we have written the lambda expression for the given functional interface. Okay. So one more thing to see here is, so we no need to specify the parameter type also, right? Because that also can be inferred, right, from the interface definition. And since it is a single expression, single line expression, yeah, so we no need to enclose it within the curly bracket. Okay, so we can remove that. So since we are not we are using a single line expression, so we no need to put a return statement also. Now this is also will work fine, right? So let's run this code. You can see here it ran fine. So that's all for the quick demo. Variable capture. Lambda expression can use instance or an static variable of the enclosing class. The lambda body has access to the current object using this keyword. Hence, we will be able to read and set the values for instance variable or static variable, the enclosing class. But when Lambda body is trying to use a local variable in the enclosing scope, then a special situation occurs that is called as variable capture. So local variable can be used inside the Lambda body, but we need to take care of few things. Okay? See, the local variable when we are using within the Lambda body, it has to be treated as an effectively final one. Okay? So that is, if the variable refers to a primitive, it should not be updated, or if the variable points to an object, cannot be reassigned. Yeah? So, and one more thing we need to take care is that it should be assigned, means it should be initialized before using it inside the Lambda body. So these situations are clearly described in the screenshot. As you can see here, the counter is an instance static variable which can be accessed inside the Lambda, and it can be also be updated. Yeah? But when we are trying to use a factor which is a local variable in the enclosing scope of main method, so when we are using that, we need to use it as an effectively final one, means we should not update the value of that variable, and the compiler also will complain when if it is not initialized. That's all for this video. I hope you liked this video. If you really like the content, please like the video, share it with your friends, and subscribe my channel. Thanks a lot, and see you soon in another video.